All right, we're about to do a confirmatory factor analysis here in R. So first things first, I'm going to go ahead and open up our data set using these lines, which if you're not familiar with, we're using Read Excel to just read some data out of an Excel file that I have ready. And boom, there we go. We see CFA in our console now, and it's got all these variables in them. Basically, what we've got here is three, or basically it's a data set that's gone through EFA, and we have three factors, each with differing numbers of items. So DJ has 5, PJ has 7, and then IJ has 6. We're not going to use all of them in this demonstration, but you could use all items for each factor. Basically, what we're doing here is confirmatory factor analysis. So we've already done an exploratory factor analysis. We have an idea about these three factors, and now we want to see, based on the items that we have and the data that we have with those items, how well the model of the three factors fits. Yeah, so let's get right on into it. The first few lines here, this is actually going to be pretty simple, by the way, in R. The CFA itself is not super hard to conduct. We're basically going to be seeing a lot of numbers, statistics that R is going to spit out of this, and it's just going to be up to us to interpret what they mean. But that's a good thing in terms of what we have to do in R, because it's not super complicated. But yeah, let's get on to it. First, we're going to load in the library Lavaan. It's the package that we're going to be using to actually run our CFA. And we're going to run this set of code, CFA1. We're going to push basically the model for the CFA into this CFA1.model variable. This is kind of a weird little thing. I'm going to go ahead and do it. And you can see now that we got CFA model pushed. If you're familiar with R at all, you might notice this is kind of weird. There's no commas like you might expect in a normal code, and that's just kind of how the model for CFA is set up. You got your different factors on each line, and it's the spacing that matters here. So make sure that you have your, and I have some comments here that I'm sure you can read, but make sure that you have your factors and then all the items on your factors on a given line, and then on the next line, a return over, you have the next factor and its items, and then the next factor and its items, and so on. I'm doing 4 items for each factor. You could do more if you wanted to. You just add them on to the line. And I kind of picked them semi-randomly. You can see 5s in here for like no particular reason before 4. I mean, the order doesn't matter, but so yeah, I've got a random mix of the questions, but I have 4 for each one. Don't have to do it that way, but that's just what I'm doing for this example. But now that we've got this kind of floating in space as a model, we can go ahead and take that model and actually run the CFA on it, on the data based on that model that we've built. So what this function is doing, it's a CFA function. That's why it's coming from the Lavaan library. And yeah, like I said, taking that model that we just built and using the CFA data set or basically fitting the CFA data from the CFA data set. Man, that's getting kind of confusing. Fitting the data from that CFA data set that we imported onto this CFA1 model that we built up here. And pushing that into a variable called fit. So let's go ahead and run that one. Boom, now we have fit. It's got a bunch of uninterpretable jargon inside of it. So to make that into something that we can actually use, we'll go ahead and call a summary of it. This kind of confused me at first when I was looking at it. So for whatever reason, I decided to make the variable that we pushed it into called fit. I mean, it's a reasonable name, I think, but this fit measures equals true actually has nothing to do with the fact that this is called fit. It's fit measures is an argument within the Lavon version of summary of the summary function. And what's that going to do is basically if we just called the summary a fit, it would give us a bunch of information about how the of what the information that basically this CFA function used to fit the data. And that's not as useful to us. What we're more interested in are these fit measures, these indices, to kind of like basically say how good of a fit is our model. And that's what fit measures equals true is going to give us a lot of those different tests to determine goodness of fit. So I'm going to go ahead and run summary, and we're going to see a bunch of stuff pop up in the console. I think I called this the console earlier. It's the environment, whatever. This is the console. Yeah, so we got a bunch of stuff. You can see the number of iterations that I took to converge on, number of observations. Obvious because we already knew that from our data set, but I guess good that it aligns with what we expected. We got here an estimator for maximum likelihood. I mean, I guess I didn't mention that we're using the maximum likelihood method of fit. And this is our actual model that was built. And it's got, you see this minimum function test statistic is lower than what is down here, which is our baseline model. Basically, you're going to expect that this is the baseline model is going to have that really high statistic, and your actual fitted model is going to be less because you're wanting basically the whole idea is that as it's better fit, it's going to get lower. But that doesn't matter too much to us. We're coming on these CFA or CFI and the TLI values. These are your like goodness of fit indicators. So you can look at these and compare them to cutoff scores that you might find. I'm using Hugh and Bentley 1999, and their metric for these two is that if it's over 0.95, then it means it's a good fit. So we're looking good so far. These are more indices of fit that I'm not going to mess with, but if that's your cup of tea, that information is there for you. RMSE is going to be the next one that I want to look at, and according to Hugh and Bentler, the cutoff score for that is 0.06, so 0.07 looking good. And this little suggestion here of greater than 0.05, I wouldn't trust it necessarily. Yeah, I mean, you can see from the confidence intervals here, and based on the recommendation from Hugh and Bentler of the cutoff score of 0.06, that's what I would go by. I'm not really sure where R is getting this recommendation from. But yeah, I mean that again, that's kind of subjective, and it's just up to whatever cutoff value you choose to use. Then we have our standardized root mean squared residuals, which Hugh and Bentley recommend a cutoff of 0.084. So that's not looking so great. So that might be kind of concerning, but it's the only one so far that is concerning. So I would say that this is not too concerning, that the fit looks pretty good so far. And moving on to this kind of stuff, you see this is just like scores for the items and how they compare to the other items within that factor, and that's really just used in the process of fitting, and you have it here if you wanted to look at it. basically they take the first one and fix it to 1 and then see how it all compares. It's not really information you really need to look at because it's just used in the computation of these fit indices. But you have it if you want it, and you also get covariances of the different factors. So again, kind of the same idea. And variances, again, same idea, all used in the process of determining the fit, but not really needed when you have these fit measures. You can pretty much just go by off of those. It's just under the hood peeping in. I have this line here. That's another summary line. It doesn't really add too much, but it just adds 2 arguments, which is basically saying, oh, I want to see standardized results for the fit, for the model fit as well, and then I want to see R-squareds too. So we can go ahead and run it, and I'll scroll through it really quickly. Let's go back to the top. Scrolling. Okay, yeah, here's where it starts, and you see stuff is exactly the same as it was before, exactly the same, but boom, we've got some standardized versions of the model fit information. So cool. If you wanted that, now you know how to do it, and then R-square as well. So yeah, and I have written under here like this is it is exactly the same function as this one up here, but just showing you kind of how these options play out. Okay, cool. And so now that we know how that works, kind of, let's go ahead and split into 2 categories in the data set. We have a dichotomous variable of sex. 1s are males and 2s are females. So we're going to go ahead and use that and split the data file into these 2 new data files of CFAM and CFAF. Which, oh god, undo that. Always hit control before you click enter. Cool. And here we go, new data sets, CFAF and CFAM. And you can kind of briefly see when I click that these are all 1s, those are all 2s. Cool. So now we have a male data set and a female data set, so we can run the same exact kind of thing to fit just to these data sets instead of the overall CFA data set by running CFA model. And we can use the same model because we're just switching what data we're referencing, not the model. So cool, we're going to make a new fit variable called fitm, and I'll go ahead and run the summary for it, why not? So yeah, summary already run. Yep, it's right here. You're going to see the same exact kind of stuff. Again, relatively low here, pretty high here. Checking out with the CFI, cut off pretty close to 0.95. Might be a little bit concerning, but not incredibly. Stuff I don't know about. Cool. RIMSA, yeah, well above the 0.06. Okay, cool. SRMR, still kind of being weird. Okay. And then the stuff we don't care about. Okay, cool. Let's run it for females as well. Man, I only have a minute left. I don't think I'm going to finish in one video. Okay, that's all right. We're going to run that. No, we're not. Shift is not the same as control, as it turns out. Okay. Yeah. So again, same kind of stuff. Let's, I guess, look at the values, because why not? Yep. That's as we expect, slower here. These are checking out, which is good. RMC checks out, which is cool. And yeah, SRMR still being weird. Cool. So pretty consistent with what we had just found with the overall for both of them. There was a little bit of a difference in the CFI, I think it was, but overall not super concerning. Yeah, and so I guess I'm going to stop this video here because I'm about to hit my 15-minute mark, and when I come back, I'm going to explain the measurement and variance stuff.